Hi everyone. Today I'm going to talk about our project on making large language models more interpretable and controllable using concept bottlenecks. LLMs or large language models are now used in a lot of everyday systems like sorting emails or flagging harmful content online. They usually work very well, but they also have serious drawbacks. When a model makes a decision, we can't easily explain how it reached that conclusion. Everything happens inside a huge network of numbers that people can't really interpret. This becomes an issue when we want accountability. Imagine a system tags an article as political instead of sports, or it flags a harmless comment as toxic. Right now, it is really hard to tell whether the model makes a reasonable judgment or it relied on some misleading signals. Fixing these mistakes often means restraining the model rather than understanding what went wrong. Recent research has shown that concept bottlenecks, large language models, can be just as accurate as traditional models. However, they are simply important unanswered questions. We don't know how strongly these concepts actually control the model's predictions or how reliable they are across different inputs. Most existing experiments only involve straightforward tests, such as distilling a single concept entirely, and they do not explore what happens when multiple concepts interact or when concepts are only partially adjusted. This leads to the main question of a project. Do these concept bottlenecks provide real causal control over large language models' behaviors? Or are they just appealing explanations layered on top of a complex system? Our hypothesis is that if a concept bottlenecks are faithful, then adjusting a single concept should predictably shift the model's output. For example, reducing the influence of a topic-related concept should make the model less confident in that category. Increasing a sentiment related concept should push the prediction into a consistent direction. These effects should remain stable, even when multiple concepts are modified at the same time. To study this, we reproduced the original CV-LLM experiment and extended them with more detailed analysis. We performed systematic concept interventions, measuring how predictions and confidence levels change as we modify concept activations. We also built an interactive tool where users can type in text, adjust concept values using sliders, and immediately observe how the model's prediction changes. Overall, the project evaluates whether interpretability methods truly reflect how models make decisions, and it provides a practical way of people to understand and test and control large language models. Thank you.